Let's take a look at how to solve some basic trigonometric equations. We're interested in finding solutions to these three equations on the interval from 0 degrees to 360 degrees, where we include the endpoint of 0 but not the endpoint of 360. Alright, well, starting out, so the sine function will be 4/7. We can think of this as y over r. And so I want a y value of 4 and a hypotenuse of 7, an r value of 7. So that'll happen in the first quadrant because sine is positive in the first quadrant, but thinking of sine because it relates to y values, sine is also positive in the second quadrant. And so there'll be a second solution over here. And so we're interested in finding two solutions. I'm interested in finding the angle value of this solution. I could call it theta. Theta 1, I guess. And I'm also interested in finding the angle value here of this second solution. And I could call that theta 2. Because this second solution will also have a hypotenuse of 7. I could create an angle with a hypotenuse of 7 and a y value of 4. Using our calculator, we have these inverse trigonometric functions. So if sine of theta equals 4 over 7, then theta equals the inverse sine of 4 over 7. And so in your calculator, we can enter inverse sine is the second command above the sine function, and so I could enter 4 over 7. And I'm in radian mode, I think, so let me change to degree mode. Sorry about that. But it's a good thing to keep in mind, right? I want answers in degrees, and the calculator just gave me an answer in terms of radians. So bringing that command back, I get 34.8 degrees, which makes sense because the value of sine at 30 degrees is 1/2, and so this is a little bit more than 1/2. And so one solution for theta, the solution for theta 1 is 34.8 degrees. Thinking about the other solution, well, they're related. If theta here, if you think about the symmetry in this picture, if theta is 34.8 degrees, then the reference angle over here has to be 34.8 degrees. And so the value of theta 2, using that symmetry, the value for theta 2 has to be 180 degrees minus 34.8. And so if I take 180 degrees and then subtract our previous answer, I get 145.2. So those are two equally valid solutions to this equation. So we get two equally valid solutions. Theta can equal 34.8, or theta can equal 145.2 degrees. A similar process can be done for our second equation. So let me try to shift things down here, and let's look at tangent. So if tangent equals -3, tangent is y over x. And so if tangent is -3, it means we have -3 over 1, or -3 could mean 3 over -1. And so we might have a positive y value of 3 and a negative y value of 1. Or we could have a positive value of 1 and a negative y value of 3. So those are two separate solutions. And likewise, I can think of them as theta 1 and theta 2. So one angle is going to be this angle. I can call that theta 2, I guess, to keep my colors consistent. And the other solution, because I want 0 to 360, it's going to be this angle. And I can call that theta 1. To actually get a value for this problem, again, we can use the inverse trigonometric function key, this time for tangent. So if I take second and then access the inverse tangent command and type in -3, I'll get an angle measure in degrees because we're in degree mode. I get an angle measure in degrees, but it's a negative angle, right? So what comes out of the inverse trigonometric function for -3, I get this negative angle, -71.6 degrees, which is a solution, but it's not one of the solutions that we're looking for. We're interested in angles between 0 and 360. So to find the positive angle that's coterminal to that, which for us we're calling theta 1, to find the positive angle coterminal to that, I can find a coterminal angle. I can add 360. So if I take that -71.6 degrees and add 360 to it, we see that 288.4 is one solution. Now let's think about the second solution. So the second solution is symmetric, and I can think about it in a couple ways related to the given solution that we just found. Related to this solution, it's exactly on the opposite side, so it's actually kind of symmetric to the origin. And so to get from here to there, what I can do, I can think of that as taking away 180 degrees. Because it's right on the other side of the circle, so it's kind of halfway around the unit circle, or halfway around a full rotation, half of a full rotation. And so theta 2, one way to get to the value for theta 2 is to take the value that we just found, 288.4 degrees, and subtract 180. And so we end up with 108.4 as a solution. So we have two solutions for this second equation. So the two solutions for this second equation, the first one, theta 1, is 288.4, and the second solution that we found is 108.4. So let's look at one more example. Let's say I want to find the angle that makes secant equal to 5, secant theta. So secant, of course, is related to cosine, and so first let's maybe translate. So this means that cosine of theta is equal to 1/5, right? Because of the reciprocal relationship. Secant of theta is exactly equal to 1 over cosine theta. So if I take the reciprocal of both sides, I end up with cosine of theta is equal to 1/5. And so with our calculator, I can take inverse cosine of 1/5. And that gives me one angle. Again, kind of putting this into the context here, I can think of this as x over r. And so the angle that we see here, we're comparing an x value and an r value. So the x value is 1 and the r value is 5. And the solution that we just found, we get a solution of 78.5 degrees. But there's a second solution. So thinking about cosine and secant, they're positive in quadrant 1, but then because it's x over r, it's also going to be positive in quadrant 4, because the x coordinate is positive there. And so there's a similar place, a similar position of 1 and then an r value of 5, but in this sort of negative y direction, that would give us a secant ratio of 5. So that second angle, if you think about it for a moment, that second angle, it's related with symmetry to the first, but it's symmetry across the x-axis. And so in terms of the angles here, that means this reference angle is going to be the same. So the reference angle is going to be 78.5 down there. And so if you think about the red rotation, that's coterminal. We can think of that as kind of coterminal to negative 78.5. And so to get our second angle, we just found that theta 1 equals 78.5. Theta 2 is going to be 360 minus 78.5 degrees. And so I could take 360 and subtract that answer that we just found, and we get 281.5. So there are a few basic sorts of trigonometric equations that we can solve, and in general, for one rotation around the unit circle, for a basic trigonometric equation where there's nothing fancy inside the trig function, these will generally have two solutions. And we can find one solution using the inverse trigonometric functions, and then find the second solution thinking about symmetry and maybe making a sketch and trying to figure out the angle value relative to the first. So let me end with a question. Take a few minutes. I encourage you to take a few minutes and try to solve the equation cosine theta equals negative 1/3. And try to find both solutions on the interval from 0 to 360. I hope you enjoyed the video. Thanks for watching.